Okay, so in the question given, draw a cycloid of a circle of diameter 50 mm for one revolution. Also draw a tangent and normal to the curve at a point 35 mm above the baseline. So first in the question we understand what is cycloid. So cycloid means it is nothing but a curve generated by a point on the circumference of a circle that rules along a straight line. You can see in this diagram clearly. So there is a circle on the circumference of a circle there is a point P. So as it is roll along this straight line, what happens? It is forming an curve here. Okay, forming an curve. So this curve we call that as a cycloid. Okay, the curve generated by a point on the circumference of a circle that rules along the straight line. Okay, you can see that point P, as this circle rolls along this straight line, it is forming a curve here. So this is what we called as a cycloid. So in this question we have to construct a cycloid of a circle of diameter 50 mm for one revolution. So for one complete revolution we have to draw the cycloid. So that is the first thing we will be constructing, that is constructing a cycloid of a diameter 50. Okay, that is first we draw a circle, then we divide into 12 equal parts, then we draw a straight line, then again we divide that straight line again into 12 equal parts. Okay, then the procedure starts. Okay, now we have to find out the circumference of this circle. Okay, we know the formula, that is 2 pi r. Okay, the diameter given in this problem it is 50 mm. The radius will be 25. So it will be total 157 mm. So if we convert that into centimeter, it is 15.7 centimeter. That means first I'll be drawing a circle of 50, dividing into 12 equal parts. Okay, and then drawing a straight line which is of length 15.7 centimeter. Okay. Okay, now we can see I'm measuring a here radius of 25. Okay, 25 mm, nothing but 2.5 centimeter from the scale, and I'm going to draw one circle here. Okay, here I'll draw. Okay, okay, now I have to divide this circle into 12 equal parts. Okay, so we know it is, if we are dividing a circle into 12 equal parts, it is 360 divided by 12, that is 30-degree inclination we have to take. Okay, I'll use this protractor. Okay, mark for angle 30, 60, 90, 120, 150. So what I'll do is, using the scale, can draw the lines for an angle of 30-degree difference. Okay, now we can extend these lines. Okay, okay. So now we can see this is completely divided into 12 equal parts. I can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now I'll be drawing from this point. Okay, a length of, how much it is? The length of 15.7. okay, 15.7 centimeter. So can keep the scale here and mark a point of 15.7. okay, then draw a straight line. Okay, so now we have to divide this straight line into 12 equal parts. So for that, what I'll do, just draw one line here. Okay, and I'll take compass. Okay, take compass, and I'm going to measure any length. Okay, any length you can measure and cut the arc, because we have to divide this line into 12 equal parts. Any length you can measure and cut 12 parts. 2, 3, 4, 5, 6, 7, okay, 8, 9, 10, 11, 12. Okay, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, what we have to do is we have to join this point with this point. Okay, now parallelly we have to draw the same lines so that it will be divided. So that's why I'm using the ruler scale. Okay, now it is divided into 12 equal parts. Okay, so now I can write it as 1, 2 dash, 3 dash, 4 dash, okay, 5, 6, 7, 8, 10. Sorry, so we can write this is as 1, 2, 3, 4, 5, 6, 7, 8. This is 9, this is 10, 11, 12. Okay, so now we'll draw parallel lines here. Okay, parallel lines. Okay, so center point, you can see as this circle rolls over any reference point, the center point remains the same. Okay, so for that, okay, now here you can see 1 and 11, we get it on the same point. 10 and 2, same way. Okay. 8 and 4, 7 and 5, and then finally we have this 6. So now after this we have to mark exactly the perpendicular points so that we can mark a C1 C2 like that. Okay, so for that I'll using different color sketch. Okay, so parallelly, so this from point C1 okay 2 3 4 5 6 7 8 9 10 11. Okay, so that we can give this as C1 C2 C3 C4 C5 C6 C7 C8 C9 C10 C11 C12. So whenever the circle rotates here, the center points will be remaining same. Okay, so that's what we have written here. Okay, now here for pointing this, tracing out the point, we will be using different color sketch here. I'll give this as P1. Okay, P1. So what we have to do here it is, so you have to measure this radius length. Okay, radius length we have to measure. Okay, and from this point C1, okay, C1 we have to cut the arc on this, that is our C1, and then we have this P2, and then we have this C3 here, and then we have this point C4, and then we have this point C5, then we have this point C6, and then we have this point C7, and then we have this point C8. Okay, and then C9 will be here. Okay, C10 we have exactly here, and then C11 we got it here, and then finally we have the C12. Okay, so now we can mark these points. So where we are getting this is P2, P3, P4, P5, P6, P7, P8, P9, okay, P10, P11, and sorry, this is P10, P1, P2, P3, P6, P7, P8, P9, okay, we have done with the naming now. Okay, this is, we have to neglect from here. Okay, P12, okay, you have to join P12, P2, and P22 we have this P3, P32, P4, P42, P5, P52, P6, and then P6 to P7, P7 to P8, P8 to P9, P9 to P10. Okay, here P10, P11, and P11 to P12. So now we can dark this one. Okay, different color. So this is what the cycloid is completed. Now we have to draw the tangent and the normal. Okay, tangent and the normal. So in the question, given, also draw the tangent and normal to the curve at a point of 35 mm above the baseline. So you can see in this question, so we have to construct a 35 mm line. So this is our baseline. Okay, this is our baseline. So 35 mm we have to consider. So from this base, so 35 mm exactly where it is touching the arc point, I'll mark. Okay, that point as M, I'll mark. Okay, this point. So I'll draw one straight line here. So from this point, so I need to measure the radius length, this length of 25. So we have measured, and then we have to cut an arc. Okay, we have to measure the radius length. Okay, which is already measured. So from this point of M, okay, you have to cut on this center line. So we mark that as X here. Okay, now draw a straight line. Okay, parallel to this, draw. Okay, this is your end point. Okay, now we have to join, okay, this N and M with a straight line. Okay, now exactly perpendicular to this, okay, that is what our tangent. Okay, this is your normal. Okay, you can give this n1. So now exactly perpendicular to this line, if you draw a line, that is what your tangent. Okay, so mark for 90 degree. Okay, okay, that is your tangent. I'll write t dash. Okay, so that completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching the video. Okay, draw an epicycloid of a circle of diameter 50 mm which rolls outside a circle of diameter 180 mm for one revolution. Also draw a tangent and a normal to the epicycloid at a point 135 mm from the center of the tangent. First we are going to learn what is epicycloid here. Okay, epicycloid means it is a curve. It is a curve traced by a point on the circumference of a circle rolling on the exterior of another circle. That means here there will be two circles. One will be the bigger circle, one will be the smaller circle. You can see here, if I consider a point on the circumference of this smaller circle, as it rolls over on the surface of this exterior of this another circle, it is tracing a curve here. Say if I want to join, just for an example, say from here to here, then from again here to here, like this. So the curve which has been traced by a point on the circumference of this circle, as it is rolls over this another circle. So what is that curve what we got? Okay, that we called as epicycloid. Okay, epicycloid means it is a curve traced by a point on the circumference of the smaller circle which is rolling over the another bigger circle. So this is the bigger circle on which it is rolling for one complete revolution. That the curve what we get, that we called as a epicycloid. Okay, as per this question, we have two circles. One is of diameter 50, another of diameter 180. So that means we have the two diameters. One is small d. Small d we have 50 mm, and capital D we have that is 180 mm. So if I am drawing the bigger circle, we have to find out an angle for how much I have to take an angle. For that, we consider that as a theta. Okay, theta is equal to small d by capital D into 360 degree. So if we are substituting the values, the angle what we get, that is 100 degree. That means first I will take a radius r of this is r equal to 90 mm. 90 mm will consider, and then draw an arc for 180 degree, 100 degree. And then after that, from the one end, I will be considering a radius of say 25, then drawing a smaller circle. Okay, and then the procedure starts. Okay. Okay, here using compass, I'm measuring the length of 90 mm, because we have the, you can see in the question, we have the diameter of 180 for the bigger circle. The radius will be 90. Okay, measuring that. Okay, after measuring that, you can take any reference point here. Okay, so I'll consider this as a reference point for a 90. Okay, and for this point I'll draw one line, straight line, because we have to draw exactly at 100 degree, right? I'll consider this length first. From this reference point I'll join. Okay, after this I have to take protractor. Okay, so for considering an angle of 100 degree, exactly at 100 degree, say 90, 100 here. Okay, so here also draw one line. I'll mark a point. So I'll draw another line here. Okay, so I'll complete this arc. Okay, so it is exactly having an angle of theta equal to 100, which we have been find out, and this capital R. Okay, to show that it is of length capital R 90. Okay, 90 mm. This is done. Now the same way, so here we have to draw another circle which is of radius 25. So you can see in this question, small d we have, that is 50, means 25 mm we have to consider. So for that I'll take from the scale, measure 25. Okay, so here so here if I extend in a straight line, so I have to extend. Okay, here only I'll draw one circle which already we have measured it for 25 mm. Okay, okay, here can give this is smaller 25. Okay, so what I'll do, I'll be extending these lines. I'll be dividing this circle into 12 equal parts. Okay, so here as a reference you can see, so here we will be dividing this circle into 12 equal parts, means 30 degree. Okay, 30, 60, 90, 120, 150. Okay, I'll be extending as I'm drawing the lines. Okay. So we have divided the circle into, okay, 12 equal parts. Okay, so after this, so we can give the naming here. You can give here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what we have to do is we have to measure the length from here. Okay, to extend from all these points. Okay, I'll be extending this one first. Okay, so this is first point is done, the extreme corner. Now from point number 7 measure. Okay, next now point number 8. Next point number 9. You can see that is our center point. No, point number 9 we have to take 9 and 3. Next point number 10, 10 and 2 same. Next point number 11. Okay, so this is we have completed. Now again we have to divide this 100 degree into 12 equal parts. Okay, now we have to divide this into 12 equal parts. So we have the angle of 100 degree. So if we divide into 12 equal parts means we'll get 8.33 degree. So first what we do, we are going to divide this thing into 8.33 degree. Okay, in between I'll take. Okay, okay, after this I will take a compass. I'm going to divide this by measuring this length. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think it's not possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have to take a little more than that. So this method we call as a trial and error method. Okay, so I'll take little more than that. Okay. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think how much? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. So little again more than that we have to take. Okay. So divide into little bit more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think I'm taking a little more here. I think it's also not possible. Little less. I have to take 1, 2, 3. Okay. So this method we called it as a trial and error method. Yeah, after trial and error method we are getting this 12 equal parts. Okay, now from the center, measuring this distance from the center, we're drawing one line. The center will be remaining same, right? So I'll be drawing that, and then now I'm going to extend these lines, okay, to the center. Okay, here 1, 2, 3, 4, 5, 6. Okay, so now we can give the naming for this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, can give C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. So this will be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Okay. Now by measuring the distance of this radius, okay, now we have to cut the arc, say from this C1, so we have to cut here, this is first point. Next from C2, next from C3. Okay, the length will be same. Okay, then C4, C5, C6, C7, C7, C8, C9, C10, 11 and C12. Okay, so now you have to join these points. I can give these points name. So I'll write this one as P1, P2, P3, P4, P5, P6, P7, P8, P9, okay, P9, P10, P11, finally P12. So now I have to join this. First I'll draw with the pencil and then we can dark. Okay, from here 1, P1 to P2, P2 to P3, P3 to P4, P4 to P5, P5 to P6, P6 to P7, P7 to P8, and then here P8 to P9, P9 to P10, P10 to P11, P11 to P12. So now we can dark this. Okay, use the same sketch here. Okay, this completes the epicycloid. Now we have to draw the tangent here. So for the tangent, you can see draw the tangent and normal at the epicycloid at a distance of 135. So that means we have to measure a distance of 135 from the scale. Okay, so we can measure 135. Okay, then can cut an arc from here, from this point. Okay, so this point we call it as a M. Okay, now we have to measure this radius, that is 25 mm. Okay, from this point exactly it has been cut. Okay, cut an arc on this center line, and this point we consider that as a X. Okay, now you join this with the straight line. Okay, and where exactly it is cutting, give this as N. Okay, so now we have to join this M and N with a straight line. So M dash I'll give. Now by using protractor here, exactly at this point I'll march. Okay, mark for 90 degree, and here I'll be drawing one tangent line. Okay, tangent line. This is our T, this is our T dash. Okay, so this completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching the video.